Hi, this is Miss Jensen, and today we are going to talk about matrix operations, adding, subtracting, and multiplying matrices. So matrices have dimensions, rows and columns. If I look at this matrix here, it has 2 rows and it has 2 columns. This one is considered a square matrix because it's a 2 by 2. The dimensions are the same, looks like a square. All right, if I take a look at these matrices, how many rows does it have? 1, 2, 3, 4. How many columns does it have? 1, 2. So this is a 4 by 2. 3 rows, 4 columns. Okay, rows are first, columns are next. In order to add and subtract matrices, they need to be the same size. You add and subtract the corresponding elements. So you add and subtract the corresponding elements. This one, if you can look at the first one, the rows and the columns are the same. This has 2 rows, 3 columns. The second one has 2 rows, 3 columns. So I can add the corresponding parts. 3 plus 2 is 5. Negative 1 plus 4 is 3. 0 plus 7 is 7. 5 plus 0 is 5. 16 plus negative 6 is 10. And 4 plus negative 3 is 1. Okay? We're just adding the corresponding parts. The same goes for subtraction, but again, the dimensions have to be the same. This has 3 rows, 2 columns. This one has 2 rows and 2 columns. So this is no solution. We'll just put no solution. Can't do it because you're not going to have matching parts. Once you try to add something to the bottom, there's not going to be anything there. But I look at the next one. This one is fine because it has 3 rows, 2 columns. Same with the second one. This time I'm going to subtract corresponding parts. So I'm going to go 4, have to pay attention to the minus. 4 minus 9. We have 7 minus negative 21. So this is a little trick. 7 minus negative 21 is actually 7 plus 21, which is 28. Little tip. Instead of worrying about the negative every time, remember how you can add the opposite? So if you don't want to kind of keep referring to that negative, we can add the opposite of all of these. Well, opposite is 0. And then we have to just do the same thing. So negative 2 plus negative 2 is negative 4. 5 plus 0, negative 0. 0 plus 5, and 6 plus negative 6. Now, if you don't like that, that's fine, and you can keep going. Leave the negative if you don't like adding the opposite, but that's just an option. All right. Scalar multiplication. So scalar multiplication just means we take this number that's right in front, this k, and we distribute it to everything on the inside, okay? So here we're given 4 matrix, A, B, C, and D. So for scalar multiplication, this is the only example, this 2b is the only example where we're actually multiplying the 2. All the rest are just different examples of adding and subtracting. So for example, if I'm doing A minus D, 1, 4, negative 3, 7. I'm just going to subtract D. Okay, D is negative 3, 4, 7, 0. Now, of course, you have to make sure the dimensions are the same. So this is 1 minus negative 3, which is the same as 4, 4 minus 4, which is 0, negative 3 minus 7, and 7 minus 0. Again, if you prefer to add the opposite, you can do that. If I look at C minus B, I should be able to do that. The dimensions are the same. I'm not going to take the time to do that right now. But A plus B, this is no solution because dimensions are not the same. Dimensions are not the same. So that one is no solution. I want to do this one with scalar multiplication. So if we have 2b plus c, I'm going to fill it in. So b is 230. And 0, negative 3, 7. I'm just going to do this part first. Remember, you always multiply before you add and subtract. So if I multiply by that 2, 2 times 2, 2 times 3, 2 times 0. That is 2 times negative 3 is negative 6. 2 times 7 is 14. Okay? We would go ahead and add the second one, which is C. I'm going to take a peek at what C is. 2, negative 7, 6. 2, negative 7, 6. And 1, 6, 9. But now that we have added the corresponding, or multiplied the 2 times everything, now we're going to add the corresponding parts. 4 plus 2 is 6, 0 plus 1, 6 plus negative 7, 0 plus 6, negative 6 plus 6, 14 plus 9, which is 23. Okay, so we've talked about adding, subtracting, and scalar multiplication. Probably the hardest thing is multiplying matrices by hand. Kind of the key here is the columns of the first must match the rows of the second one. They have to match, and if they do match, the dimensions of the final matrix are the outside numbers. Okay, so we'll do a couple of these. So this is one where you have to kind of watch carefully because it's a little tricky. But first of all, I need to see if I can do it. This is a 2 by 2. So A is a 2 by 2. And C is a 2 by 3. I can multiply these because these are the same, okay? So that makes it okay. My final dimensions are going to be 2 by 3. So I'm going to make a little final matrix here that's a 2 by 3. I'm going to move it over a little. 2 by 3. 2 rows, 3 columns. Okay? So if I write down A, 1, 0, negative 4, 2, and I copy down C, all right, I am going to find each answer by multiplying and then adding the corresponding parts. So I'm gonna go rows times columns. So first row, first column is gonna go in this spot here, okay? So this is what I'm gonna do. I'm gonna do, I'm kind of matching this part up with this. So see this 1 and the 0 here? I'm gonna go 1 times 0, and I'm gonna add 0 times 2. So I'm going left to right and straight up and down. 1 times 0, 0 plus 2, 0 plus 0 is 0. Already looks like a 0. Okay, now I'm going to go to the next one. First row times the second column. So notice I'm going to go left to right. 1 and 0, 3 and 1. So I'm going to go 1 times 3, 0 times 1. 3 plus 0 is 3. Okay? So if I go first row times second column, it's going to go in the first row, second column spot. Do another one here. First row times last column. So 1 times -1, 0 times 4 gives us -1. Now that I've done that, I am completely done with that first row. So I'm going to ignore the 1 and the 0, and I'm going to go on to the -4, 2. I'm going to go to that first column. So I'm going to go -4 times 0 plus 2 times 2. I get a 4 there. I'm going to go to the bottom row, second column. -4 times 3 plus 2 times 1. -12 plus 2 is -10. And if I go to the bottom row, right column, I get -4 times -1 plus 2 times 4, which is 4 plus 8, which is 12. That's it. So that's the hardest part. I just want to point out one other thing. Again, the dimensions have to be the same. So I want to point this out with B and C. B and C, I'm just going to check and see if it's okay. B is a 3-row, 2-column spot. C is 2 rows, 3 columns. This is a 3 by 2. This is a 2 by 3. So, final matrix, it's like this is okay. Final matrix is going to be a 3 by 3. All right, so this is what we would do. This is what we would use to fill in. Whereas if I look at one of these other examples, this A times B, notice up here, A is a 2 by 2, B is a 3 by 2. So A is a 2 by 2, B is a 3 by 2. These are not the same, so this is a big no. No solution. I guess we can just say no solution. All right, the other one that's on the right is done on the notes. Like I said, this part is the toughest part of the matrix multiplication, or the matrix multiplication is the toughest part of the matrices. So look over that example that I did in the left carefully. Look at another example in the notes as well. That's all for now. Have a good day.